All right. Another calculator tutorial that goes in chapter 2. This feature is called the inverse normal. Okay. And it's right along in chapter 2 with the normal CDF feature. Okay. You should kind of view these two features together. Normal CDF will give you a percentage. If you tell the calculator all about this normal curve that you're working on, what its mean standard deviation is, and your location, it'll tell you, like, here's the percentage of data that relates to that problem. Inverse normal is the exact opposite. Okay, we know our location, but there's some kind of, excuse me, I take that back. We don't know our location, but we know it in terms of the percentile. Right? We have the percentage, but we're like, we want our location as a piece of data or, as a z-score. Okay? It could be in the context of the problem, could be a z-score. But you go back to second vars, but instead of option 2, it's just down as option number 3. Okay? So at this point, you may have a prompt where the calculator is expecting you to tell it some kind of area. That's another calculus thing, that the percentages are actually, if you're standard normal, it's the area under the normal curve. Okay. Bottom line for us, we got to tell it where we're at. Okay. Number 4 in your note says we're at the 20th percentile. I'm going to tell it that 20% of the data is to the left. Okay. And here, you'll also have prompts to change the mean and standard deviation. If I just leave it like this and I don't say anything, what's it going to assume the mean and standard deviation are? 0 and 1. Okay? Both of these features will go standard normal unless you tell it otherwise. Okay? If I don't, and I hit enter, that answers as a z-score. Okay? If you're at the 20th percentile in a normal curve, your z-score is like negative 0.84, right in that range. Number 5. Okay, here you have to be a little bit tricky. This is probably the most important thing about this inverse normal feature in terms of using it. The area that you put in has got to be to the left. Okay, it's got to be to the left. So this said in number 5, 45% of all observations are greater. Okay, I got to put in the opposite. That's the same thing as saying is 55% are less. But 0.55 is the number I want to put in. And there you go. It's at a z-score of like 0.13. Okay. Now, unfortunately, in your notes, I did not get an example of using this feature in context. But let's just flip around number 10, the Rafael Nadal example. Okay, it used a normal CDF, so be really clear here. I'm just messing around with the problem. Okay, number 10 about what percentage of Nadal's serves would be 120 miles an hour or more. That's a normal CDF. Okay, I'm going to say let's have the answer. We saw that it was 20%. Okay. So if I go second vars, and let's say I'm looking for what speed of Nadal's serves are at the 80th percentile. 80 below, 20 above. We're still talking about the same location. Okay. In fact, I kind of like this one because we know our answer. Right? It should be 120 miles an hour. Okay. So now if I say, all right, in this distribution, I'm at the 80th percentile. All right. But you know what? The data I have is centered at 115, and it's got a standard deviation of 6. And there you have it. Okay. That's in the units of the problem. The only reason I threw this one in is I want you to see with inverse normal as well, if you want to change the mean and standard deviation to what the problem is, feel free to do that. Okay, the that the calculator feature will allow you to do that.